I'm Dr. Santosh Vishwakarma. Today, we are going to cover the topic of object-oriented databases. So I hope that I'm audible properly and my screen is also visible.
Yes, sir.
Okay, fine. Thank you. So let's begin the session. So the topic for today is object-oriented databases. So as you can see in the introduction that object-oriented databases adds the database functionality to object-oriented programming. Very important part of the entire session. As all of you are aware of that there has been, lot of benefits with cover to object-oriented programming. Okay, so now we are going to integrate the programming concepts in databases. So it creates more manageable code bases. So the learning objectives are that you'll be able to understand what is object-oriented databases. We'll also discuss the object-oriented DBMS terminology. We'll also recognize what are the basic interfaces and the class structure. We'll discuss the various features of object-oriented, such as type hierarchies and inheritance. We'll also give some examples, and at last we'll talk about the drawbacks as well as advantages of object-oriented DBMS system. Now, students, I hope all of you are aware about the term data models. Okay, when we started the subject, we have been discussing about data models. So very important part to start the subject. So how to define data models? So data models can be defined as collection of concepts for describing data. All right, I repeat again, data models can be defined as collection of concepts for describing data. Okay, for describing the data. Now, what are the components of data models? So you have learned that the components of data models are data. Okay, let me write also. It may be data, then data relationship, data constraints and semantics. So this has been very, integral and important features once you are going to take any data model. So data model components are the data itself, the relationship which exists between data, the various constraints which we use to say the conditions. So the constraints and the semantics structure. Okay, so all these are, important part of data models. And you have also learned that data model may be one of the types such as based on trees. It may be based on trees. It may be based on graphs, or the very important that you're learning from previous few sessions based on relations. I repeat, data models may be traditionally, when we start the course, we have already gone through this concept that there may exist different data models, and the data models may be based on tree. Once it is based on tree, it is hierarchical data model. Okay, so the data model which is based on tree concept, and as a student of computers, you are, I hope, that very well aware about how we can utilize the concept of trees in terms of databases. So tree means hierarchy. There may be some root node, and then we can have some intermediate nodes and so forth. So tree, it depends on what? The hierarchical data models. There are different advantages and disadvantages of tree-based model or tree data model. Okay, that is known as hierarchical data model. Next, we come to graph-based. So graph means that we have better interconnectivity between nodes. Okay, so that if data model is based on graph, it is known as network data model, the second one. And the third one, which we are very fluent to work with, we understand every concept we have gone through is based on relations. So the third data model is based on relation, and that's why the name given, relational database management system. Now, after this, we come up with other data models such as object-oriented DBMS and or otherwise object relational DBMS. So we'll explore both their terminologies. We'll also find it out what are the advantages and what are the drawbacks with compared to the previous one. So this tree and graph, they have been very traditional one when we started working with different earlier, softwares. So like working in terms of hierarchical or network data model, it comes with its own drawbacks because we can only create a parent-child relationship once we are going to work in terms of trees. Graphs, we can have many to many relationship, but still there have been issues of pointers and how to implement everything. So these are the major hurdles with this. So the more flexible, the more convenient, the more usable, the more acceptable data model is the relational data model. But now we need to integrate the features of relational data models with the concept of object-oriented programming that we have seen in many of the courses. Okay, so let us go ahead and try to understand what OODBMS is and what it offers in terms of combining both the features. So let me go through the one by one points on the slide. An object database is managed by an object-oriented database management system, and that is known as OODBMS. All right. The database combines object-oriented programming concept, and this is, I can just put a asterisk over here. Okay, this is very important. Now you may ask yourself, what are the object-oriented programming concept? What is the core of the object-oriented programming concepts? So obviously you will be very happy that the core of the object programming is the object itself. Okay, this is at the core. And what is object? So object is somehow it just grab the behavior of what exists. Okay, whatever you want to implement in terms of instance of the class. It's a very important definition, and I hope you have gone through the basics of object oriented programming in any of the courses that you have like in your academics. So this integrates the object concepts, the class concept, and the features of object-oriented programming, and with relational database principles. So in the subsequent slide, we'll also explore what are the relational database principles that are very important, very integral, very faithful in terms of implementing any concepts which doesn't have any conflicts also, right? Now, the main characteristic of objects in ODMS is the possibility of user constructed types, right? Very important part. An object created in a project or application saves into a database as it is. So this is somehow, it's a very flexibility given to programmer point of view. If you can create object, you can call it, you can first of all save it, and whenever it is required, you can call that object. Okay, so this seems a lot of flexibility working with object oriented DBMS. Now, object-oriented databases directly deal with data as complete objects. Okay, so the thing is that what I said at the core part, you are going to deal with objects. All the informations comes in one instantly available objects package instead of multiple tables. That seems to be very important if you're working with the object references. So you can have all instances, whatsoever is required in a single object. Now, how we work in data RDMS, we work in terms of tables. Okay, we have multiple tables. We have the concept of referential integrity. We have the concept of joining and so forth. All that thing can be done. But in terms of object, we can have a one instance available object package that can be referred again and again wherever it is required. So students, whenever you may have any issues, any doubts, or you want to discuss more, you just raise your hands. So I will check it out with you after 20 minutes. And if there is any point of discussion, then definitely I will be like taking your doubt and we'll discuss more on that. So this slide or this, the different points, what we have discussed covers that at the core of, object-oriented DMS is the object feature of object-oriented programming, right? Now let us see like how we define the object-oriented databases or what are the integral part of object-oriented databases. So as you can see, if this has been a object-oriented database, this one, so this combine the features of object-oriented programming. Okay, this combine the features of object-oriented programming, and it also combine the features of relational databases. Now what is it? So in object-oriented programming, once we work with objects and classes, so we may go through the polymorphism concept. We know inheritance, you can inherit properties, data from the base classes, and we can also merge the data and the methods in a single object, that is encapsulation. So all the features that you know of object-oriented programming can be utilized in terms of object-oriented databases. Now, very important, coming to the right side, relational database all the way from the very beginning. You have been taught about the relational databases. So we work with integrity, either it is domain integrity or key integrity or referential integrity. We need to, have all the features that is a must for maintaining databases. We also look out the various issues with concurrency, because no one wants that the system should support only one transaction or one process at a time. We want that multiple processes, multiple transactions. So once we are going open for concurrency, we may deal with lot of conflicts. Like suppose we may deals with read-write conflict or write-write conflicts and so many things. So overall, we want that the system must support concurrency without any conflict. And that's why you have seen the various topic like serializability, okay, serializability in the concept of DBMS, and so forth. Like suppose concurrency control protocol also we have gone through. Third is query processing. So it's a very important part, that how the query is going to be processed in terms of producing the results that may be part of proper getting from the SQL. So query processing comes with the optimization issue also. So all these things which are very integral to relational databases, they must be a part of object-oriented databases. So if you have been like a question that what justifies the object-oriented databases concept. So we have good and good concepts at both sides. We have the features of object-oriented programming, which has been listed over here, and at the same we may features relational databases. Now, if you can just focus on this diagram. So object-oriented programming, what I said, that you may embed it with different features of object-oriented. Like suppose this has been the base class. Okay, if this has been the base class which consists of the data or the methods. So this base class can be derived further. It can be derived further in the subclasses. So we say it is derived class. We can work with that, and obviously if the object has been defined, it can be instantly called whenever it is required. This is the object-oriented concept with lot of features like inheritance, okay, and different types of inheritance that you already know about the object-oriented concepts. Now, in relational data, we can have multiple tables, and we can show the connectivity of multiple tables with the concept of foreign key. For example, suppose this column and say this column, this one. Okay, so this considers to be primary key of this table A, right? And this is table B. And suppose this consists of the foreign key. So foreign key always refer to one of the key column. Okay, it may be primary or unique key column. So this foreign key refers to another table through what? Through this concept of referential integrity. So we have also learned about the referential integrity concept, referential integrity concepts, and so forth. So this is the relational things what we have learned earlier. So now you are going to understand the different concept of object-oriented databases. So if we can define the objects are the basic building block, as you can see in the slide, and an instance of a class where the type is either built-in or user-defined. Now classes are the blueprint for objects defining the behavior. Okay, and third is methods which define, okay, methods determine the behavior of a class. And there may be pointers. So pointers help access elements of an object database and establish relation between objects. So these are the few key points which I have taken at the very beginning of the presentation. So you must be like able to know that we are going to define objects. We need to understand the classes. We need to know about the methods, because behavior is very important once we are going to define the additional features of databases in terms of object. Now, pointers help access elements of an object database and establish relations between objects. So at this moment of time, let me check if there is any doubt. Students, you can just raise your hands, digital hand, and I can just find it out. Is there any question from your side? Okay, so Abhishek Sinha. Abhishek, allow mic. Yes, Abhishek, you can unmute yourself and you can speak out.
Good morning, sir.
Yeah, good morning, Abhishek.
Sir, what are the uses of object-oriented database? We have already relational database model, but what are the basic uses of object-oriented database? Why it will come?
Yeah, as far as use is concerned, Abhishek, the use is only one, that we need to satisfy the user query. Okay, if user is coming up with a information need or obviously a query, so the use of the any database system, either it is hierarchical or network or object, the use is that we must be able to satisfy the query. But this is just a superfluous statement. Apart from satisfying the user query, if the data is available, you need to store it, you need to manage it, you need to control it. That is the main thing. And once we are going to work with object-oriented databases, like at this moment of time, you may be able to understand that we are not going to work traditionally what we have seen in terms of relational databases. Somehow, we are going to incorporate the features of object-oriented programming, which we have seen in terms of databases also.
Yes, sir. Then how we will create object-oriented database?
Yeah, that's a good question,
How?
Abhishek.
Yes.
Yes, that's a perfect point. So actually, it's not like that we can directly, like suppose in RDMS, we directly create tables because we have some open source platforms, we have some online platform also. But
Yes.
have you heard about NoSQL?
Yes, sir. Yes, sir.
Yeah.
Yes. No,
Which
sir.
NoSQL you have heard and worked?
MongoDB.
Oh, that's good. Have you worked on
Mongo.
MongoDB?
Sorry,
Have you worked,
sir.
Abhishek, on MongoDB earlier?
Hello.
Have you worked on that software? I'm audible, Abhishek?
Yes, sir. Yes, sir. Uh, no, sir. But I basic understand about what how it will work.
Perfect. That's good. So like it's the same like NoSQL, which stand for not only SQL. We can go far away other features from SQL. So similarly, there exist some very well defined tools, okay, or platforms for object-oriented databases. All right. So by use of that tools, definitely you can create objects which justify the features of working with object-oriented DBMS. So later in my slides also, I will come up with certain features of different ODBMS which you can download and which we can work out also.
So it means MongoDB is a object-oriented database.
No, I cannot say at this moment of time because there are some NoSQL which may combine some features of that. I'm not saying like that MongoDB is object-oriented database system. That is NoSQL. Okay, that's a part of NoSQL. But there are
Yes.
like Velocity DB and some other system. They combine the features of NoSQL as well as you can say object databases.
Okay. Sir, I have one question more. What
Yeah.
is serializability?
Yes.
Serializability.
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 Okay.
Yes, sir.
Yeah.
Yes, sir.
Yeah. Okay. Can I go through the slide? I will explain there only.
Yes, sir. Sure, sir.
Yeah, sure. Thank you. Okay, the question which has been asked by Mr. Abhishek is serializability. Okay,
Yes.
because I have to use the word, so it's better that we also understand serializability. Suppose if you're working with a schedule, say S1, like this, and the schedule is a concurrent schedule. It is a concurrent schedule. I hope all of you understood what is concurrent schedule. So concurrent schedule means that we can have multiple transactions. Like suppose we can have T1, T2, T3. So schedule itself means that we have a set of transactions. So this schedule may have three transactions, T1, T2, T3 like this. We can have transactions like this. Okay. Now, what is concurrent? Concurrent means suppose like if T1 gets started, so then T2 also gets started without the completion of T1. Then suppose T3 gets started, then again T2 gets started. Then again this T1 gets started, then suppose T3 gets started. This is known as concurrency. I am not writing the code because it will take so much of time. Like suppose you can write few codes also, but in case of concurrent schedule, as you can see in the diagram, that T1 doesn't finish over here, but T2 gets started. After T2 not finished, T3 gets started. Then again after T3, T2 came back. After T2, T1 started, and so forth. So this is a pure concurrency. Okay, because and if this has been the other part, like suppose there has been a schedule which is known as serial schedule. Okay, the second is example is serial schedule. Serial means which is not concurrent, means one by one. So if I can show the example of T1, T2, T3, which is serial. Now what will happen over here? Suppose first of all T1 gets started, so T1 will entirely run until T1 doesn't finish, no other can start. Now suppose T2 gets started, T2 will run entire, and then T3, like this. So this is serial schedule and this is concurrent schedule. Right, now what happens when we are running something in concurrent mode? So there may be, some sort of conflicts. The conflicts may be that, like suppose if T1 is updating something, T2 is also updating on the same, so there may be conflict, that which values to consider. So in case of concurrent schedule, there may exist some sort of conflicts, and this conflicts may produce incorrect results. Incorrect results. Okay, so this again I repeat, because we are running in a we are using the common variables, we are using the common approaches, we are just moving from, I think you know about the multitasking system, same concurrency system. It may consist of certain conflicts between the transactions, and that may produce incorrect results. Now what is incorrect results? Because we want concurrency but we don't want this. If at the if you sacrifice this thing with terms of incorrect result, that the entire thing is going to be blushed out, nothing will remain perfection. So we don't want incorrect result, but we want this speed. This is quite fast with compared to this. Now to make this competent, to make this correct, there is a concept known as serializability. What is serializability? What will do, this concurrent schedule S1 will just try our efforts. The schedule S1 should equal to, okay, by any means the entire results at last should equal to S2. So this concept is known as serializability. Now you may be worried, sir, why this is equal? Because S2 is always correct. If you run one by one, there is no sharing, there is no conflict. First of all, T1 runs and that thing has been done, then T2 comes, then T3 comes. So this is known as what? 100% guaranteed to be correct. This will always be correct. This will be correct or incorrect matters. Now, how come we can justify that this concurrent will be correct? So what we'll do, we'll make a concept that the concurrent schedule is equal to the serial schedule, not in terms of running, in terms of results at the last. If this happens, this is known as serializability concept. Okay, and we used to say the concurrent schedule S1 is serializable to S2. I repeat, in concept of, see this, if S1, look at this, if S1 is equal to S2, then we say this concept is known as serializability. And we can also define this schedule S1. I will also write for you, schedule S1 is serializable to S2. That's it. Perfect. Now you come up with all the issues. Now S1 is serializable. So if this result is correct, because I have written this is guaranteed to be correct. If the result of S2 will be correct, so result of S1 will be correct. Okay, because we have made it equal. Now you will come again over here and see this incorrect. You will just cut it out and you will say it's correct. So now we got the fastness, we got the efficiency, and we got the correct result. So serializability is the concept which makes the concrete schedule as correct.
Got it, sir. Got it. Thank you,
Yeah,
sir.
I hope you got it, serializable, although it was a little bit long, but you asked me, so that's why we have explained this.
Yes, sir.
All right.
Got it. Thank you.
So okay, thank you. So we'll go ahead with the remaining slides. Let me and if you feel any time, and also Vishek, you asked me about how to make the objects of, definitely we'll go ahead with that in subsequent sessions also. You can see there are few tools which are openly available. So if you can just download and if you can start working with that, definitely you can create objects such like the same way you have used the MongoDB as NoSQL. Now, once you are learning the object databases, you may come across two words, ORDBMS and OODBMS, right? So it's better that we can also discuss some features of this. So this ORDBMS stand for Object Relational Database, okay, which acts as an interface between relational and object-oriented databases because it contains aspects and features from both models, right? And if you are purely working with the entire object-oriented features, right? So that is OODBMS, which stand for Object-Oriented Database Management System, that supports the creation and the modeling of data as objects. Now, ODBMS also includes support for classes of objects and the inheritance of class properties. That's the main feature of working with, I can say, object-oriented programming also. Incorporates methods, subclasses, and their objects. Now let me also define few features. So at least you must have an idea that why. Although still at this moment of time we can go through describing, but still there has been lots of limitation also working with object-oriented databases. So that's why the most universally accepted databases is still relational database management system. But still at this moment of time, because you need to understand that, you need to work that, and might be you come across certain projects where dedicatedly you need to work with object-oriented databases. So that's why let us go ahead and let us see what can be done. So some features are the query language. So language to find objects and retrieve data from the databases. As you said now, what it can be done through this object-oriented databases. So it's a list of things, and you can see there are few of systems which are openly available also that is very accurately work with all the features. Now, transparent persistence. So its ability to use an object-oriented programming language for database manipulation. If you want to modify the methods, or if you want to apply encapsulation or inheritance, so that can be very well done with terms of transparency. Some there are a dedicated list of programmers I have seen that they very openly say that we are very habitual working with this kind of databases. You give me lots of data, you give us big data, you give us the transaction format will convert into some sort of this object-oriented databases. Third is the very important. Without this, no, I can say a database system can be stand up. Okay, so that is ACID properties. So ACID transaction guarantee all transactions are complete without conflicting changes. Now, what are these ACID properties? So these are atomicity, consistency, isolation, and durability. I am very sure that you have already gone through these properties and you know the exact meaning of this. Atomicity, consistency, isolation. Why I'm writing this? Because without this, there will be no value of working with multiple transactions. And durability. So this, not only one, all four jointly, they are the heart and soul of working with databases. Atomicity says that no partial transaction is allowed. Okay, I repeat, atomicity means no partial transaction is allowed. Either the transaction should be at 0 level or it should be at 1 level. That is atomicity, right? Because atom cannot be divided na atoms on the same pattern. So if suppose something happens in between and there is a power failure, there is an interrupt. So what the system will do? System will take back to 0. System will never rely on a partial thing. That something is partial remain. If you can see, like once you perform, some transactions in through ATM machine, if you are withdrawing something and by any means the money has been deducted from your account, but you didn't get the cash. Sometimes it happens. So in that case, you doesn't need to worry because it's a partial transaction, and whatsoever deduction has been done, it will be again replicated to your account. Might be suppose if you are booking a railway ticket and the money has been deducted from your account, but the ticket was not generated. So what happens? Tell me what happens? Automatically the money will be credited in your account after a period of 1 day or 2 day, whatsoever the rule exists. That is atomicity. Consistency is somehow it is whatsoever transactions we are going to work with, it will just shape the database system into consistent means correct state. It means that system should not go into an incorrect state. All right, that is consistency. Isolation is the beauty of working with multiple transactions. What is it? Every transaction will have an illusion that I am the only one. Okay, there may be multiple transactions, there may be concurrency, what I have shown in the previous slide, But here, every transaction must see itself that the only one, that is isolation. And then we come up to the point of durability. So durability means if a transaction is successful, okay, if a transaction is successful, then its result must be stored, right? So if there is any sort of errors, if the transaction is successful, its results should be stored properly into databases. That is durability. So these properties, I hope in relational databases, you have enjoyed with all the properties with certain examples. Now, once we are going to work with any systems, any databases like object-oriented databases, we must be confirmed with this that ACID properties or ACID transaction properties are there, existed. Now, database caching, the next one. So creates a partial replica of the database, allows access to database from program memory instead of disk. So somehow, as you know, that DMA method or the paging method, if you're working with a large database, so there should not be an issue that always referring to the database through the disk. Okay. So that is database caching. And recovery means if there has been any some sort of disaster, so we must have a proper mechanism, proper recovery technique in case of application or system failure. So these are the features, and obviously luckily there exists different type of ODBMS which supports the feature. So let me check if there is any question from your side. Yeah, so any students have any doubts, so we can discuss on that. Okay, Sudhir ji, I will just give the permission, allow mic. Now you can unmute yourself and you can speak out. Sudhir ji.
Sir, am I audible, sir?
Yeah, you are very properly audible.
Thank you, sir, for taking this session on the database.
Yeah.
So my question is this: suppose a language support dynamic inheritance.
Okay.
Is it a better? Is dynamic inheritance a better way to implement join operations?
Yeah, so dynamic inheritance always they have been a very good method, very good approach, and I am with your statement that yes, it can be done very well. But it has been this what you said, the dynamic inheritance. It has been limited to various softwares because some software they allow these features, and there exists some software which doesn't allow. So as far as your question is concerned, my answer is always yes, but it is limited to the extent of the software which we are using.
Thank you, sir. I understand.
Yeah. So thank you, Sudhirji, for your question. Any other questions?
Not from my end, sir. Thank you. Thank you so
Okay.
much.
Okay. Sure. Sure. Thank you. Fine. Fine. Okay, so I come to the main slide. What are the main benefits? So the capability to modify an object definition without influencing the remaining system, classify the methods, classify the message. Okay. Now express the entity's derived attributes and the ER model as read-only messages. So because once we have seen that in terms of designing also, database designing, so we have worked extensively on terms of entities, and we have seen different type of entities like strong, weak. So you will be glad to know once you will start working, because the scope of this session is very limited and somehow you need to know the basics terminologies, and you also need to little bit about how we can extend. But if you work out with different things, and if you go through some other readings or some research paper readings, you will find it out that whatsoever has been discussed in terms of traditionally in terms of in part of entities, relationship, entities association, types of entities, the attribute types in ER model, that may be classically, okay, that may be classically implemented in ODBMS. That's the beauty of this. I recently, I was working in a project where how to have the designing concept, and I will share those things with you also, that ER model has been drastically changed in terms of extensions or extending, because people they are implementing how to recognize the various normal forms just looking the ER model. Okay, I will just give one very simple example, like you may understand my words. This is a simple entity, say E1. this is a entity, say E2. Now E1 and E2 has been associated with each other like this through a relationship, and suppose this is R. So what is the job of R? R is a association or relationship which joins E1 and E2. And suppose the cardinality is 1 to 1 like this, okay, or say 1 to many, doesn't matter. Suppose I'm taking 1 to many. Now what does it mean? It means for one instance of E1 we can have multiple instances of E2. That's very much feasible. Now how this can be done in terms of object-oriented databases? Cannot we implement the concept of inheritance over here? Just have a thought. Just have a thought. So, and this is very much okay. And also we can see that cannot be, people are working on this direction. Just having a look of this ER diagram, cannot we say this is in 2NF, second normal form, or first normal form, or third normal form? Cannot we say? Now you people are working on this level up also, that if we can have the attributes associated with this, we can define that if there is no multi-valued or no, what we can say, like suppose all that are atomic, so that is in first normal form, because we say na, when it is in first normal form there should be no multi-value attribute. Okay, there should be no multi-value attribute, right? There should be no composite attribute, there should be no composite. So these 2 points you can directly see from the attributes. So this is somehow, that's why the fourth statement you can just check out with the designing part also. Now, as far as the analysis is concerned, that how to begin and how to work out with that. So first of all, the very famous thing, as you know about the object-oriented programming, the identifying the objects, the organizing the objects by creating object model diagram. Okay, as far as the designing is concerned, this can be taken as the designing scope of designing, defining the internals of the objects and object attributes. Okay, defining the internal of the objects and object attributes, defining the object actions, which particularly talk about behavior, where I said earlier that methods, and describing the how the object interacts, okay, whenever it is required. So as you can see, the object, very important word, paradigm, is based upon objects that aims to incorporate the advantages of modularity and reusability. Okay, I can have asterisk over here for both words, as you understand that how important this is. And further, you can say this relies on the encapsulation of the data and code into a single unit. Very important part. Okay, this is very important once you are using. I hope you are familiar at the initial level, at the fundamental level, that what are the various features of object-oriented programming which makes it very unique. So encapsulation, it means where you can combine, and we'll have a slide over here itself where we'll see the different types we can have encapsulation. Now an object has association with a group of methods, okay, a group of variables, and a group of messages, right? So we can have different association. So as you can see in first part, where it consists of a group of methods. So every method is a set of code to execute every message, right? And the method submits a value as a reply of the message. When we talk about the group of data objects, so again, it can communicate with the itself object, and then you can say a group of messages and objects react to this messages. Now there are certain approaches that we'll briefly discuss, because the intention is that you must go through the implementation part also. So let me cover it in a fast way, that object-oriented architecture is a design way based on the division of responsibilities for an application or system into individual reusable and self-sufficient objects. So there are various approaches available, as you can see in the contents also, which have been provided to you. So distributed client server approach, right? At this moment of time, I think we are going to explain this in subsequent slides also. So it's better, let me show you all four. So that is how the data is going to be accessed, the object clustering, and the heterogeneous operations. So what is the first one? Distributed client server. As you know that the client, the working methodology between client server is the request and the response approach. So this, there has been different, nowadays people doesn't work in standalone system. They want a network areas. They want workstation that may be part of the different groups. So that can be part of ODBS very easily. Now suppose the offices, electronics offices, case, CAD system, computer aided design, then client system manage applications specific like utilization and updating of separate objects. And once suppose we are going to work with different workstation or server architectures, so there have been three approach which I propose. The first one is object server, second is page server, and third is the file server approach. So let us see one by one in the subsequent slides. So in case of object server, so this obviously, as the name suggests, the object is considered as the key element. Now, what do you mean by key element? It means the unit of transfer from server to client, because there has been a system, okay, having working with as or behaving as server, and there may be one to many clients. Okay, so there may be different clients. Now, how the request and response is going to work? Okay, it's very important part. So I show few clients C1, C2, C3, 4, and so forth. So the basic object is considered as the unit of transfer from server to client. So both machines store objects and are competent of performing methods in objects. Object level locking is carried out easily. Students, maybe you have gone through the concept of locking, like what is lock-based approach and how it can be used for concurrency control protocol, like two-phase locking protocol. Might be you have also gone through in your academics the graph-based protocol, graph-based concurrency control method, where we apply, the exclusive lock on all the transactions wherever the common variable is going to read out. There are a lot of things in the similar pattern we can perform the object locking, and there are different mechanism on the software which I'm going to show next. You can perform this. And the drawback of this approach is overhead related with the server interaction need to access each object, right? Because object here we have considered as the key element, okay, the core element which is used between server and client for the transfer of the information. Next, come to the page server, right? Now, in this case, page is considered as the unit of transfer from server to client. Okay. Now, this page concept is very important in terms of computer science different architecture point of view. Why? Because page itself consists of different data. It may consist of, and page can be taken as a unit of storage also. So this thing works in number of applications, but there have been certain drawbacks that it can be accessed only on the client. Therefore, all objects that an application uses must be transported to the client, and it's very difficult to implement object level locking, right? In case of that. So because a page may consist of multiple objects also, as you can see, right? So this is the second part, but as far as the granularity is concerned, definitely the page, as far as the storage space is concerned, it's going to have bigger with compared to the previous one. And next is file server. So in this approach, the client processes of ODMS have an interaction with a network file service for reading and writing database pages. This approach makes the process of the server implementation simpler because there is no need to manage the secondary storage, because itself you are working in terms of file itself. Now again, network interaction for accessing data. There may be the major concerns. Now what is like, the core part of file server, you have seen all three. First, where we have discussed the key element is going to be the object. Second is the unit of transfer is going to be something bigger in terms of pages. And third, we also work in terms of the entire files, which consist of multiple pages itself. Now coming to the next part, that is the data access mechanism. So as you can see, the contents, that's the assessment of object-oriented DBMS products should consider the procedure required to shift data from secondary into a consumer application. Very important point. Again, I can have a asterisk over here. It doesn't mean like that simply you can create a database storage, and you are just create a interface. You have created a form interface, because once you work in three-tier architecture or multi-tier architecture where we may deal with database server separately, like suppose this has been a application server, there has been a database server, DB server, and this is the actual server database where we can have. So in this case of the not database, we can have a server. Okay. So where the entire data has been stored. So whenever we work with different aspect like this, then database, access mechanism should be clearly defined. Okay, how the data is propagating from this part and from this to application server. So usually this necessitates interaction with the server process, probably across one network. And the cost and procedure of releasing locks and updating objects that are returned to server should always be considered. So that's the second part. And again, if you can ask me, said like out of all the methods that you are explaining now, I will say this is a very important method, data access mechanism. Now the next is object clustering. So access on application to a specified object signifies a high possibility that it may be also access other related objects. Now the basic techniques for packaging objects into clusters is to have each cluster object subsume responsibility for construction, maintenance, dispatching, and execution of held objects and operation. Now when I speak about clustering, okay, when I speak about clustering, so I hope you know the basic definition of clustering, that it's just a set of similar objects, set or collection of similar or a group of similar elements, right? Like suppose if I can create a cluster 1 over here, this is cluster 1, and if I can have a cluster 2, right? So similarly, you can say that in cluster 1, I can have somehow the elements which seems to be same. They possess some common attributes. And in cluster 2, suppose if I have this kind of elements, so they still possess certain elements. And if we cannot have any element over here, that can be defined as outliers as well. That is different study. But once we are going to work with object oriented system, then we can still maintain a group of objects that possesses almost same thing, same properties, and then they can be utilized according to their requirement in the entire programming structure. And I also come to the last one, that is heterogeneous operation. So it means that a method in which applications can work together. This is done by sharing access to a common group of objects. And heterogeneous itself says that if you are going to work with heterogeneity, there have been different terms in terms of architecture point of view, in terms of access point of view. Still, we should be able to understand how we can utilize the concept of ODMS. Now, to make object-oriented DMS an efficient integration method, it must support data access in heterogeneous proceeding surroundings. That's very important because it's not like that all the way we are going to work with similar pattern systems. If you want to support heterogeneity, that will be definitely a added advantage working with object-oriented database systems. Now, as the slides inform that NNT is an object-oriented programming that describes the property of objects that distinguish from other objects also. So with object identity, objects can contain or refer to other objects. Identity is a property of an object that distinguishes the object from all other objects in the applications. And the object identity concept is essential in applications. However, it does not relate to relational database tuples, right? So this is somehow different with relational database system, where every tuple is recognized through a common, either primary key values or something else. And here we can define objects in terms of object identity. There are few issues related to object or object identity. So we used to say that there may be a unique key related to object, and that may be identifier keys, and that is generally used in all database systems. So using identifier keys for object identity confuses identity and data values. Now there are three main issues. The first is modifying identifier keys, right? Because it doesn't allow, and if you can see in the velocity database or some other databases also, it's not allowed to change even though they are user defined descriptive data. This is the most critical problem that we face with working with this. And non-uniformity. Okay, what is this? In that identifier keys in different tables have different types or different combinations of attributes. And the major problem is that attribute to use for an identifier key may need to change again and again, depends on the requirements. And third is unnatural joins. So if you want to perform this joins, okay, because there have been different retrievals, there have been different queries, there have been different systems, they might require some sort of joins based on the dynamic requirement. So again, in that case also, there may be some issues, as we'll also explore in terms of the software part also. There are a few things that at this moment of time, because you know this the subject or the entire concept of object oriented or the entire concept of relational database also, you might have explored through SQL, something which makes us understand in more efficient manner, because just going through theory and just going through all these definitions, that may be a part of the knowledge gaining. But if you understand this, if you cope up the knowledge, the next part is apply. So you should be ready for that, how to apply all these things. But before that, let us check this slide related to identity. So the name. So how this is going to be, various forms of identity. The first may be name, second may be value. So in case of name, we have a name of a file. In case of value, we'll see what's the value, primary key in a single relational databases. Because again, what I see, like suppose if you're going to work in relational databases with multiple columns, this column is A, B, C, and you have lots of tuples over here. So how this make identical? Because suppose the values of B and C are same for every tuple. So this primary key itself, as per the definition, that it has a unique value for every tuple, that makes the things. So this is value, and it can be named as far as the identity of object is concerned. And third is built-in. So this signifies that an idea of identity is built into programming languages or the data models, and it does not need any user supplied identifier. Now, when you have gone through the concepts of object-oriented, I think I'm remaining with, okay, fine. So procedures and encapsulation, very important part working with object-oriented systems. So procedures, what are procedures? As we have seen, procedures may be used to show the object behavior, okay? How the object is going to perform, how it's going to, in terms of the functions or methods. So very important parts. If you have exposure of working with C++ language, or if you have implemented procedures, then I hope you are getting the things that how we can mimic the behavior, the necessity, and the code part itself that can be done through part of these procedures. Now, very important part where I stated at the very beginning, data encapsulation. So it refers to the process of binding together data and functions. Very important, right? If you're binding the data and functions in the single unit, it is data encapsulation. So it may be used for further interference and uses. So encapsulation is the object model concept of including process or behavior with the object instances defined by the class. Now, again, the same definition, that encapsulation allows code and data to be packed together, right? So you have your data, okay, and you have the piece of code, and that can be very well expressed through the concept of encapsulation. Now, there are certain features, as already stated in the previous slide, that once you use data encapsulation, so this data can be accessed by ODBS procedures which are related to that object, okay? And encapsulation basically signifies hiding the data inside the object from the outside classes, right? As you can show in the subsequent slide. By means of behavior encapsulation, the users of the class are not allowed to view the internal implementation of behavior. And let me show you through, if I can have this. Yes, as you can see over here, that we may have, once a class has been defined, you may have these three levels. The first is this private data, and the private data by any means it's not accessible outside, okay? Even if in the out of the class itself, it's not going to be accessible. And there may be the second category, protected, which means that it is accessible to the derived class. If you have been working in the base class, and by use of this, or suppose this is the super class and some other class like which is known as subclass, okay? So if subclass has been derived the features of this, then the data is protected, it can be accessible to the derived class. The third is public. And what is public? So the public data or the variables, they are accessible to the outside worlds. So once it totally depends on the narrative of the programmer, how they are going to work and what's the necessity. So they can work out in terms of private data, protected or public based on the requirements. Okay, so coming to the next, I can show you few, some examples of object-oriented databases now, which are free. Okay, they are free and they are, available for download also, but not of the features. I cannot say that every all the features they have that can be like readily available for download. But this I have listed that and tested also, that velocity graph, velocity DB, and some part of DB2 or otherwise intersystem. They are just freely available. You can just have a look on this, and if you wish to work out, you can download the trial version and you can see. If you can say the graph methods, so graph itself, it's in terms of graphs, how it works. So it works in terms of nodes, in terms of different nodes, and the nodes are interconnected. So let us utilize the same concept what we have seen in terms of this, because every graph can create ultimate other subgraphs like this or subclasses. So that can be very well done. And this is one I just love to work with this velocity graph system, as all the concept of objects can also be implemented. So you can just see that these are the free available, or you can say the trial version available, some softwares which supports the object-oriented databases. Apart from this, there are very some commonly used object-oriented databases, which I will explain in 3 or 4 slides because we are limited to time as well. So first is object store, which integrates the C++ or Java and provides memory persistence to improve the performance of application logic. And the very important part, which I have shown earlier, that this object database is ACID compliant, and this is a must. Until you don't provide these features, we cannot say that the entire relational things that can be embedded over here. So the responsiveness allows developers to build distributed application cross platform, whether on premises or in the cloud. That's very important. As you see, object store, but you cannot directly work because the trial is not available. But if by any means, if you got any project or if any opportunity to work with object store, you can just find it out. Whatever the benefit of C++ or Java exists in terms of object-oriented programming, they can have over this. And it is the main feature is cloud scalability, which allows database access from anywhere. And object store simplifies the data creation and exchange process seamlessly. Coming to the next one, the next is object database plus plus, same in terms of C++. So it's a real-time embedded object database designed for server-side applications, and the required external maintenance is very minimum and supports multi-process with multi-threaded server application. It also supports full transaction control in terms of serializability, in terms of concurrency. You can have real-time recovery as well, and you can just go through the features of C++ embedded over here. So this database is C++ based, and one of the main features is advanced auto recovery from system crashes without compromising the database integrity. We come across certain others, what I found very relevant that I can just show you through, at this moment of time. So objectivity DB utilize the power of objects and satisfy the complex requirement with big data. All right. Now, as soon big data, the word come, you may come across, sir, most probably we are going to work with not only SQL. Okay, that is no SQL. Yes, but if you want to embed the features through objects, definitely you can come across different features like this, okay, of all these languages. Now we have seen all the good and good. Let me collect it in terms of advantages. But again, I will speak out that still the leading one is relational database system. So we also need to discuss about what are the drawbacks, okay, what are the disadvantages of working with this kind of system. If it has been so simple, if it has been so flexible, then why not everyone who is maintaining databases in a small scale may be using this? So the answer is no, but still there are a lot of benefits which has been listed in the slide. So once we are working with big data in terms of increasing complexity or a wider variety of data, okay, we can definitely work because this is just a SQL or example of SQL in terms of MySQL, which has been shown. So this is limited, not all the features implemented, but that if the data is going to be changed, if the data is going to be a little bit in terms of semi or unstructured, as you have seen in NoSQL also. So it supports one of the very important features, easy to save and retrieve data quickly, right? Then the third is seamless integration with object-oriented programming languages. It's easier to model the advanced real-world problems because why? What's the reason behind the popularity of this object-oriented language? As all of you understand, but same can be integrated with some sort of database also, and extensible with custom data types, right? And also, I'm not writing everything that in terms of object you can mimic the behavior of the real world. You can show the classes, you can do the inheritance. That is self-understood. But based on this points needs to be considered, okay, in terms of advantages. And if I can speak out the drawbacks, so as you can see, some drawbacks not as widely adopted as relational databases. Again and again, I'm just focusing on this, that you come across relational databases for actually storing a small databases, maintaining it, controlling it, accessing it, lot of features. But as far as ODBMS, still it's not considered as a as you know equal as relational databases. It's no universal data model, lacks theoretical foundations and standards. As you can see, we are again saying that object-oriented features, but what are the standards that can be calculated for the relational databases? Like suppose in relational, we have very clearly defined about the integrity rules, we have defined about the time migrations, we have defined about the join operations, all that things. But in case of this, somehow we stuck in between when there has been that kind of functionality requirement with compared to relational databases. Does not support views. As you know, views are some sort of temporary accessibility to tables, the real tables. In case of working with object-oriented databases, so views view mechanism cannot be supported. High complexity causes of performance issues, and an adequate security mechanism and access rights to objects do not exist, right? So these are certain drawbacks that you should definitely consider. Although working with RDMS seems to be very easy in terms of creating the tables, in terms of defining the constraints, in terms of defining the usability, in terms of the response to the queries, but still we can have a hand on object-oriented databases and in terms of creating objects with reference to the tabular data. So this comes to the conclusion slide, and I hope you understood about the basics of ODMS in terms of objects, in terms of classes, in terms of inheritance, encapsulation features that we have discussed, and the access mechanism. We have also discussed a few ODBMS with certain examples that surely we can explore. And we have also discussed about some advantages and disadvantages of ODBMS. So with this, I come to the end of the content on the session of this object-oriented databases. I request the learners that you can refer the module, the LMS, which has been provided to you for reference, and you can just see the very useful contents on the same. So with this note, I thank you all for being in the class. Thank you.
Thank you, sir, and happy Teachers' Day also.
Yeah, thank you. Thank you so much, ma'am. Thank you.
If you have any doubt, you can please discuss it right now.
Yes, Abhishek, I will just give the chance, and Abhishek, you can just unmute yourself and you can speak out.
Yes. Yes, sir. Sir, I have a question not related to this topic, but just
Yeah.
related to our assignment.
Yes.
So actually, sir, what is ADDIE architecture? I am confusing about this. It is a tool or just a theoretical concept?
Yeah.
What is ADDIE?
Yeah, ADDIE, which supports some distributed sort of computing. So have you referred the contents which have been provided to you, Abhishek?
Yes, sir.
Have you gone through the contents, the PDF files, the
Yes, sir.
e-content which has been provided to you in the SLM?
Yes, sir. Yes, sir. Yes, sir. But
Yeah,
I
yeah.
am confusing when I go through that.
Okay, so actually, Abhishek ji, I am not the right person to speak about the assignment because that has been given by the faculty who is taking the course. So I will just pass your question to Dr. Pankaj, and we'll discuss with him, and he will definitely reply in the subsequent sessions. Is it work with you?
Okay, sir. Okay.
Yeah, yeah, yeah. Okay, fine, fine. Thank you.
Sir, I have one question more
Yeah,
related to this
please.
topic.
Yes.
So please explain different architecture approach in brief.
Which architecture?
Different architecture approach of object-oriented database, such as clustering, heterogeneous
Okay, okay.
clustering database.
What
Yes,
what what
yes.
I have shown in the slide that I need to discuss?
Uh, in brief, if possible,
Yeah, yeah,
you
why
can
not?
explain.
Yeah. This thing like the same I have shown in the slide, or you want me to discuss something
Yes, sir.
else?
Yes.
Okay, okay,
Yes,
okay.
sir. Yes, sir.
Yeah. So actually, when I talk about the approaches, the architectural approaches, it means that how we are going to mimic the entire system, how we are going to work out with the system. Actually, Abhishek, and to all the learners, I just want to make it very clear that the theoretical definitions what you are learning over here, they are the backbone of the implementation. Once you will like if you have gone through, I hope that some sort of machine learning concepts or other things which you have like aiming for different other practices. So you have seen about clustering, you have gone through about classification and other things. So they are obviously related to some sort of machine learning or other aspects. But when we say clusters, so clusters are the common things now. Cluster means grouping. And what is grouping? So once you are going to work with objects, okay, so can you group similar sort of objects? That is object clustering. Now, this is the definition part. This is somehow just for the understanding that if you are discussing about the object clustering, it is somehow grouping of similar objects. Now, you may explore yourself. You may ask yourself why we are doing object clustering. You just have a search on this. What's the benefit of object clustering? Because object itself, they are the features. Okay, they are the runtime entities. Now, if you are going to cluster, definitely it signifies that once we are going to have a real stuff, once we are going to have a real programming approach, this can be utilized in terms of different aspects. So this was the first one I have discussed, Abhishek, and I have also discussed about this one. I think I should show you all four. Next one. Now data access mechanism also. So again, this itself lead to a very big topic because if there has been a client server mechanism, so we used to say that it is a two base architecture. We may have three tier architecture also when we have a separate database, separate application, and separate storage also. So that is three tiers. So again, how you are going to access the data, that is really important because once we have the interface, because the user is supposed to interact with the interface itself, so that's is communicating with the architecture part or it's communicating with the application part. It's very important. Then again, it's a major issue, but still, due to the limitations, I cannot work out on every aspect. But please understand that data access is going to be very crucial in terms of manner, in terms of getting it in different aspects, in terms of the different levels of mechanism. And also, I have spoke about the next one, that is heterogeneous operation. Once you are going to work with ODMS, it doesn't mean that it should be based on only one system where we are running the object-oriented concepts. It must support all that which comes into the heterogeneity part. And I hope I have answered you, Vishek. And let me go through Yalanuru Shekhar. So BMS, but yes, they support certain features of object-oriented programming.
Okay, thank you, sir.
Okay.
Okay, thank you, learners, and have a nice day.
Thank you so much. Thank you.